Greetings all. We have here three people from the University of Colorado who were instrumental in getting green chemistry into the curriculum at that school. We have with us today Bryn McDowell, who's a student in the Masters of the Environment program, specializing in renewable energy. We have Dr. Kathy Ramirez Aguilar, who manages the university's Green Labs program. And we have Dr. Matt Wise, who is the director of chemistry instruction at the school, as well as he teaches the Intro to Chemistry class. Welcome to you all. All right, I'm going to start with you, Bryn, with a simple question. Why? What drove you to, my understanding is you essentially led the effort as a student to get green chemistry into the curriculum there. Why? What drove you to do this?
Well, I feel like chemistry and learning it throughout my undergrad, you figure out that it affects you like throughout every aspect of your life. So if you're going to be doing anything with chemicals or even like the chair you're sitting on, what you're using in your computer, etc., at least you want to make it sustainable and green. And I at least had some background in green chemistry. So bringing it to other students at CU is something that I was just really passionate about. And I also have some background in renewable energy. So environmentalism is just something that, again, really passionate about and excited to see what the future holds in that regard.
Terrific. Thank you. I wanted to, I'm going to come back to the connection with renewable energy actually in a little bit. But first, Kathy, I would like to ask you the same question. My understanding from our earlier talk is that you've had an interest in green chemistry for quite a while now and been sort of eager to help make something like this happen. We'll get to the how it all happened in a moment. But first, again, to you, what drives your interest in green chemistry?
Yeah, well, I just have this great passion for sustainability in science. I mean, more than a decade ago, I pitched the idea to the University of Colorado Boulder of creating the Green Labs program. So as you can imagine, as a manager of the Green Labs program and a PhD chemist, I just had great interest in seeing green chemistry education for our students at the University of Colorado Boulder.
Matt, I'd like to ask you the same question. Why, when it came to integrating green chemistry into the course and into the Intro to Chemistry course there, which you teach, and with anyone out there with any knowledge of how a university runs, they know that changing an existing course, especially a pretty significant existing course, is no small feat. But you took that on, and why? And I at the risk of leading your answer, when we talked previously, you had hinted towards that in part was also driven by your students.
So it was. So my interest in integrating the Green Labs curriculum into our Intro Chem curriculum had a lot to do with it's kind of selfish reason. And one of the reasons is when I have students review my course, many times they say, hey, can you please do more connection with real life problems and ideas? And the Intro Chem course is actually very hard to do that because what you're trying to do is build a big foundation for the students to understand just the basics of general chemistry before they go off into other science courses. And so, partially my interest in integrating the curriculum was not so much to change it, but to add to it. So I didn't really change anything in the curriculum, so to speak. Bryn did a really good job of creating modules that stood by themselves that we could integrate in our course learning management system. So the students really could look at a lot of these topics on their own time, and we didn't have to take a whole lot of time out of class to really talk about it. So that was one of the things I really wanted to do, is kind of keep the curriculum the same, but add to it and not take away from in-person lecture time. And sort of the other kind of interest that I have in the whole program is my PhD is in atmospheric chemistry. So I have a background in this kind of work anyway, so the green chemistry interests me. And so those two things kind of melted together really well in my course.
Fantastic. I want to come back to see the push from the students, as you said, was they wanted to connect this Intro to Chemistry more to sort of the world around them. And I think maybe Matt, I'll start with you, and then Bryn, if you want to jump in. How kind of broadly speaking, how is it that the green chemistry aspects, how did they answer that call from the students? Like, what about them brings in that connection for the students? And Matt, you can toss to Bryn if you'd like, or answer.
Yeah,
that
I'll
from your
toss. I'll toss to Bryn.
Okay.
Yeah, so kind of off the basis that students wanted more like applicability into the curriculum that they're already learning, we just saw green chemistry as a really easy pathway into that. And so using different topics that, like, for example, Yale has a list of topics that have to do with green chemistry and what you can learn about. We took those topics and put them into the curriculum and then found real life examples from either news articles or like honestly applying what I've been learning in my master's program to different topics that way. And then took the lesson plans that Matt had from the original curriculum and making it apply into the real life topics through green chemistry as like the overall lens.
Terrific.
I'll just add to that a little bit. I think we kind of already knew that students were interested in green chemistry because we had given them surveys for I don't know how many years before that, and so Kathy and Bryn have all these statistics on how interested are students actually in the green chemistry topic, and it's they could actually maybe talk a little bit about what the percentage of students that were interested in green chemistry were, but it was a significant percentage of my students. So this wasn't just like, okay, we polled the students and 10% of them are interested in green chemistry and we just forced it upon them. That wasn't the case. I think the students generally had an interest in it, especially at the University of Colorado. I think sort of the environmental green chemistry idea is more prevalent here, I think, because of the area we live in than maybe some of the other places I've been.
Yeah, I'll add to that, to what Matt just said. I mean, so prior to doing this whole project, CU Green Labs had partnered with the chemistry department to conduct surveys of student interest in green chemistry. And so the results were overwhelming, and we had done it multiple times, that the students were very interested in learning green chemistry as part of their course curriculum. So yeah, we had the data there to show that the students wanted to head in this direction. And I don't have the numbers off the top of my head. I can just tell you that it was very strong, and maybe it's something that we could link in and show, as part of this.
So I guess my question then, if this was sort of percolating in the background and that interest was there, what changed? My understanding, this is about a year, 2 years ago when the ball started actually, when that became momentum enough to move forward. What changed? What sparked the change from interest to making this happen?
I mean, if I could respond to that, I would say it's because Matt came along, because those surveys were done before Matt got his faculty role in the chemistry department at the University of Colorado Boulder. And then Matt came along and he's like, well, yeah, I'd be interested in doing something. And of course, as you can imagine, we were so excited about that. And then everything came from there. So yeah, I don't know, Matt, if you want to say more from your perspective.
Yeah, I mean, I'll add to that. I mean, that's partially true, but I think the other part of it is Bryn. I mean, this is when Bryn came in. And we knew that she had a chemistry background. And it was one of those odd moments that you have that's like multiple things come together at the exact same time. And Bryn's awesome to work with and Kathy's awesome to work with. And so it really, on my end, didn't feel like I was changing a whole lot, even though we kind of, I guess, were at the end. But I think it's just like sort of us coming together at the right time.
Bryn, what gave you the idea that you could do, I mean, and I'm laughing, but I think there's probably a lot of students out there who wouldn't feel empowered to help spark this kind of change, because it is a big deal. And so what gave you the kind of the mojo to think, hey, maybe I can help, push this thing forward?
I mean, definitely Kathy and Matt. Kathy was always like very much encouraging of the fact that this was possible and that it was something that if you take small pieces at a time, you can easily build up to something that's like great and really impactful in that regard. It also was helpful having Jan as another partner in this. And so we were able to bounce ideas off of each other. So I would say that was probably like the driving force was Kathy and Matt being just so willing and helpful throughout the whole thing.
Terrific. And for the audience, Jan was another student involved who worked with Bryn on developing the curriculum. Am I correct on that, Bryn? Yeah. Jan actually I'm hoping might appear on a future episode as someone who can speak to the impact of having a background in green chemistry as a student and what that means to landing a job in the real world, because my understanding is that played a role. Stay tuned for that. But back to you all. What has been the reaction? And I think, Matt, if it's all right, I'll start with you, since my understanding is the course is now wrapping up its first year with green chemistry wrapped into it. This is the intro to chemistry class again. What reaction have you gotten from the students who are going through this?
So that's a really interesting question. If it was a negative, I can tell you I would hear about it. I promise you there has been no negative reaction to any of the content that Bryn mostly created and I kind of tweaked maybe a little bit. The very first semester we tried this, we didn't know how it was going to go. And so I offered it as extra credit. I'm kind of morally opposed to extra credit, to be perfectly honest. I think I told Kathy and Bryn and Jan that I was, but since we didn't know how it was going to go, I didn't want to put it in as course points. So of course the students loved that aspect of it because it was, extra credit. We do some post surveys, and Bryn has done a good job of doing surveys at the end of each one of our little modules that asks on a scale of what is it, one to 5 or whatever, with 5 being this was great and 1 being like, this is terrible. How would you rate this quiz or this module? And I don't think we got any really negative reactions from that. Maybe the most negative reactions we would have gotten is just like, hey, like maybe you can tweak this part a little bit because I didn't understand it. This semester, I've actually put it in as real course points. So it's not extra credit anymore. And I really do believe that the students enjoy going through the modules and learning about green chemistry. And it is also a way to add to their course grade. So I actually took away a different component of my course to put that in as a real course component. And so the students that I've talked to and just straight asked, like, what do you think about this? They've already really had a positive reaction to the quizzes and the modules that we use.
Thank you. And Bryn, as Matt was talking, it occurs to me, and folks, this is something, again, we'll link to, that Bryn and others have written basically a paper analyzing this whole process, what it took, what it's looked like, and what the future holds, which makes me realize that you may have an answer to that question as too, in terms of what you've seen from those polls and feedback, formal or otherwise. How are you seeing anything that the students are saying about having access to green chemistry in this intro class?
I mean, like Matt was saying, when we did the poll of like the effectiveness, I guess, of teaching green chemistry at the end of each of the modules, almost exclusively, they were either like a 3, 4, or 5, with most of it being about a 4. So that would be on the positive side, being like effective or like very effective. And when it came to like, they could also respond with like a written quote or like what their ideas were about it. And most people were overwhelmingly positive. If someone had something, I would say, more negative, it was more so neutral, in the sense where they were like, this was really interesting. I don't quite know how it will fit into my future career path, which again is just something that may or may not be applicable to that person, depending on what their major was. But if you're looking at it as a whole, it's been a really like overall positive response, especially if you're thinking about it as like students are having to do more work, and not really, but like more like a module or a quiz. And normally, at least as a student, that's not necessarily something you're looking forward to. And so having them actually have a positive reaction is really impactful.
So Bryn, you just mentioned, some of the students may not be yet seeing or may not see quite some of the how it might impact their future. That brings me to my next question, and maybe I'm perhaps lobbying for those students to change their mind. But seriously, my understanding is that this course over the year reaches 600 to 700 students, and because it's intro to chemistry, many of them are not necessarily chemistry majors. They are students who are taking chemistry as part of a requirement and may go off into different, study and career paths in their future. I think, Kathy, you had talked about this when we spoke earlier. What's the impact of that? Students who are not going on to be chemists, yet still having a view at green chemistry and the implications of green chemistry into how things are made and designed and play out in the real world.
Yeah, no, I think this is one of the greatest parts of this project is that the students that are going through this course are in a diverse set of majors. So they're going to go out into fields of employment that are also diverse, so a wide range of fields. And so being able to take this green chemistry knowledge with them and being able to apply it in many different areas, it's just going to have far reach. And I think that's true of other chemistry courses as well in the chemistry department. So as you know, we think towards the future and this idea of expanding this project into other courses, which I think is already being thought of, and maybe Matt could comment on that. I mean, we're going to reach more and more students, but I just think that's one of the greatest parts of this project is the diversity of majors and then fields of work that this is going to touch. So,
thank you.
Yeah, I can add to that if I may. This course is very interesting because the student population that you see in this course has a very limited science background. That's why they're in the course to begin with. So when I teach certain topics, for example, I'm just like, okay, water, right? Water is very interesting. Like you use water all the time. You boil water. Why is water boiled at a certain temperature? And then they'll start to tell me, hey, like I'm really thinking about sort of my world through this kind of like different lens of sort of scientific basis. And I think the green chemistry thing, this will stick with them. The green chemistry idea will stick with them because they're so new that I feel like if you're interested in science at all, they kind of soak up all this knowledge and they start to apply it to their real lives. I guarantee you they're thinking about it in their real life. There's no question.
And I do just want to quickly jump in and clarify that the majority of students, like we ask in the survey if they think this will benefit their future career paths, and the majority of them do say that they do see that connection despite having a variety of different majors. So more so the last question when I was answering was about like the specific students who might have something more neutral to say. That was their reasoning, but that's overwhelmingly the case.
And Bryn, actually stay with us because I want to bring this back now to, so you have a background in chemistry, or you studied chemistry undergraduate, and now you're doing a master's in renewable energy. You're, they're adjacent, but maybe not obvious to everyone. So from your perspective, green chemistry into renewable energy, what's the connection there?
Yeah, I mean, at least personally, I was doing research on PV solar panels and we were using a lot of hazardous chemicals, but our PI at the time was very much pushing towards finding alternatives that weren't as hazardous to the environment, which got me very inspired in that regard that people were thinking about it. So going through COVID, I got my certification in my green labs and then went into renewable energy. But now, I mean, even at the place I'm employed currently, it's something that is being talked about and something that they're thinking of in the future. And so I think that green chemistry is taking off more and more, so which is really exciting.
Absolutely. And I mean, whether we can talk about battery composition and do you need lithium or all the different rare earth metals. Many universities and research programs are studying in green chemistry programs how to recreate batteries, how to recreate photovoltaic cells, all of which eventually, most of which boils down to green chemistry. It's this idea of reaching the people who are going to go on to, business or literature or whatever, political science, whatever, pre-law, pre-med, whatever it might be, with green chemistry, I find really impactful. Honestly, the heart of Green Chem Essential, this whole channel, is reaching those people as much as it is reaching chemists and engineers, because out in the real world, it's the CEOs and managers of Walmart and Amazon and Apple and on and on and on who are making the decisions that'll impact whether or not these companies will source green chemistry, will invent green chemistry, and bring it up through the supply chain. So the idea that you all are now sending people out into the world who will not be chemists, but or they'll be voters and taxpayers, who have a voice in knowing, wait a second, this doesn't need to be this way. What if they redesigned it without those chemicals? I think that's a really, really powerful powerful dynamic that you're creating there. Couple more questions if you'll all hang with me for a second. How you all pulled this off, made it happen, could be, I'm sure, like a 4-hour show. So we'll stick to the highlights here. You all wonderfully summed it up in our earlier discussion as Bryn and Jan sort of advocated and created the content for the course. Matt took on the hard job of integrating it into his existing Intro to Chemistry course, and Kathy, you were described as the overlord who gave, I think, the extra heart and motivation to make it all happen. But beyond that, Bryn, I want to turn to you specifically in terms of the course content. Where did you turn to? To whom did you turn to get a handle on what that content might look like?
Yeah, kind of like what I responded a little bit earlier was Yale was a huge resource that we looked to get those topic areas. And then My Green Labs and Beyond Benign are two other kind of organizations that have a lot of information out there already. So those were probably the three main sources, and the rest of it was honestly like the news for finding those like life applicable moments, or my classes at CU Boulder were also really instrumental in finding at least like examples for those topic areas.
Thank you. And folks, we'll be linking to the Yale Center for Green Chemistry and Engineering, Green Engineering, Beyond Benign, as well as the resources that Bryn just mentioned. We'll be linking to from this show. Matt, you talked about this a little bit already, but from the perspective of then integrating it into an existing course. Mm-hmm. Anything you want to add beyond what you've already said in terms of how you made that work without sort of, again, it's not an easy thing to do. So how?
Yeah. So, I mean, I think if you back up to how we originally tried to plan out how this was going to work, we wanted everything to be a standalone module, and one that a student could actually take the content, digest it outside of the classroom, which is kind of where our learning management system came in handy. During COVID, we learned a lot about how to give exams on a learning management system, and so we kind of used that knowledge to use it in the quiz format that Bryn created. I think one of the sort of, for me, I think one of the big ideas was every module or quiz that we created, Bryn had standalone content, so they would go watch a video or read an article, and then there were questions that integrated basic general chemistry topics that we were talking about the week or two before the quiz got released. I was actually just looking at one because I was like, what's the Green Labs quiz for this week? And it's a solvent quiz. And I'm like, man, okay, so we haven't really talked about solvents, but in a lot of Bryn's content that she created, there was like chemical compounds, and we're naming chemical compounds in class. And so some of the questions in the quiz were like, oh, this solvent is, whatever chemical compound it is, and it has these, ionic compounds in it, name the ionic compound that's in the solvent. And so I think it was a really kind of cool mash of kind of outside content that you could get from a video, and then integrating it in with what were the topics we were discussing in class. So I thought that was really important, and I think it's worked really well. I think we're on the third iteration of this, and honestly, we really haven't had to change much of anything. The only thing I really changed was kind of how the points were distributed in the course. So yeah, it's worked out pretty well.
Thank you. Kathy, anything you wanted to add on this regard in terms of how it all, the mechanics of putting it in place at sort of a high level?
Yeah, absolutely. One of the things that I wanted to add is that, we realized that Matt is very busy. He has a lot of responsibilities as a faculty member. So when we were working on how to do this, we're trying to think about that and be conscious of that. And so, having a student with chemistry knowledge like Bryn, and then also Jan, who was about to graduate with her undergraduate degree in chemistry, be able to do the actual work of creating the content, and then enabling Matt to just have to review that and revise where necessary. But having that model, really being respectful of Matt's time, making sure the project was not taking a lot of Matt's time, because he didn't have necessarily a lot of time to give. But in the end, it accomplished that goal. But at the same time, it gave Bryn and Jan an amazing opportunity to be able to add to their resume as they're graduating, that, and also just, I think, a sense of accomplishment that they were able to impact the curriculum at the University of Colorado Boulder. So I just think this project has so many wins in different places. So that's something that I want to bring up. Just that it's a win-win-win, I think, in many ways.
So, Kathy, if I may, I'll add a fourth win. And the fourth one is we had a really good time doing it.
Yeah.
I think that's really important, because
I agree.
Right, because if it was really, really, we didn't work together well, we didn't laugh and have fun, it would have been hard to pull off. I always like to have fun doing chemistry. And I really believe this project is one of the fun things I've done, quite honestly, in the teaching realm. So
yeah, I agree. It was so much fun. And I think Bryn might have a comment on that too. I mean, Bryn, was it fun for you?
Oh, it was so much fun for me. I mean, I probably wouldn't have had so much passion for it, I guess, if it wasn't fun. And I have, again, a lot of other responsibilities with working other jobs as well as doing grad school. And this was something I looked forward to, at least every week, to be working on or looking up or researching on my own time. So totally agree.
Fantastic. What's next? And Bryn, I have a hint of this from reading your paper, but I don't want to make any assumptions from what you said versus what's actually sort of in the works. This is intro to chemistry that you've all done this in. What is either in the works or is on your mind that you are able to share in a public way for what might be next in terms of green chemistry integration at the university?
I'm going to pass that to Matt first, and then we can come back.
Okay, so from my perspective, I really like the way Intro Chem has gone with this project. I'm teaching General Chemistry 1, which is mainly for science majors, but a lot of the Intro Chem students funnel into that course. I'm teaching it over the summer. My plan is to take the modules that Bryn created and apply it to that course. I'll probably have to rework the order of it. We've done a little bit of work with our General Chemistry 2 course. We have specific recitation periods that we use for our General Chemistry 1 and 2. We don't have that for Intro, so we can't really do it there. But for General Chemistry 1 and 2, we can integrate things into our current recitation packets. And we did that a little bit with General Chemistry 2. Was that, Bryn, last summer, I think?
Yeah, it was just last semester.
Right. So I think we can integrate this kind of idea into our whole overall general chemistry program, which would then cover, it would probably impact about 2,000 students instead of 700. And then the next idea would be to look at how we do our labs. So we have a lot of lab experiments that I personally feel like could be changed to make them more green. For example, we actually already did this a few years ago. We do this titration experiment where, I don't know if your viewers will know what I'm talking about, but you have kind of like a burette that has a bunch of sodium hydroxide in it, and you titrate an acid with it, and it takes, I don't know, 50 milliliters of the base. And it turns out that the students were going through an unreasonable amount of acids and bases during that lab. So we actually developed what's called a micro titration lab. So instead of using 50 milliliters, you'd use like 2 milliliters, and you get the same results. It's kind of impressive. I can see us doing that in other lab experiments, but it's really very hard to change a lab experiment at the University of Colorado, because if something goes wrong with it or it doesn't work right, you've got 2,000 students impacted. So we really try to, when we do change experiments, we try to kind of roll them out in the summer where we have less students. So that's kind of my idea for these kind of things, are both, things you would do in a lecture, but I think the lab is more important. So that the micro titration experiment that we did, I actually wrote a whole intro to that experiment describing green chemistry. So I made a particular effort in that one lab to introduce green chemistry, but I think there's other experiments that can benefit from it.
And the cool piece about that micro titration thing you just mentioned, it starts to echo again, on this show, we'll be highlighting as we go forward what's happened in corporate level manufacturing processes around the world, where they've been able to take, the way to make ibuprofen, for example, using far less ingredients. So they're mimicking you, you're mimicking them in terms of getting to the same result with far fewer ingredients. Kathy, we're a little bit in your territory now in terms of green labs. I want to let you all off the hook here soon, but I should, as Matt talks about changing up the experiments a little bit, is there anything at a high level that you'd want to add before we wrap up here?
Yeah, I just wanted to add that, it's been numerous years that CU Green Labs has been partnering with the chemistry department. We started prior to Matt having his current role, and the department is really supportive. I think people's time has been the biggest hurdle to getting things done. And so I just want to point out, like, the organic chemistry teaching labs, there's been a lot of switches of those experiments already to green chemistry. Other teaching labs as well. There's been other efforts as well. So it's just the support in the chemistry department for moving in this direction has been wonderful. And it's been so great to partner with them on this. So that's just, I just want to add that it's my hope, and I'm sure it's going to happen, is the chemistry department will continue to migrate towards more and more green chemistry and in other ways for the education of the students. And they already have done so much. I mean, we have with organic chemistry, we have a solvent recycling program for acetone, for example, and we've been able to get other efforts in place as well. So it's just been great to work with the chemistry department on all these sustainability, but then also green chemistry efforts. So
yeah, so Kathy, I don't know if you know this, but so we're renovating our general chemistry labs over the next couple of years, and sort of the people that are doing the renovations have specifically asked me to provide documentation on green chemistry, like what experiments we're doing in green chemistry. So that's actually, they're interested in that in terms of just even our renovations that we're having in the building over the next couple of years. So I thought that was really interesting too.
It sounds like you all have a discussion to have after we're done here. But let's close out, and I have just one final question for each of you to respond how you'd like to. Words of advice, wisdom, encouragement, or otherwise for others. So if for each of you, if others in your similar positions at other universities or colleges, or for that matter, high school or middle schools around the country, around the world, really, who might be looking at this and be like, wow, green chemistry is something that I'd like to incorporate more here. Words of it, again, advice, wisdom, encouragement, or otherwise, that you would give them. And here I'd like to, Kathy, maybe start with you, if that's okay, if you're okay.
Yeah, absolutely. So a couple of items I would give as advice. One, there's a lot of resources already out there, so this makes it more feasible with limited time. And then thinking about limiting time, if you can't do the whole course at once, don't. Just do one small piece of it. Any piece of a course or a lab, a teaching lab that you're doing, it makes an impact. So that's the advice that I would give.
Thank you. Matt, if I could go to you next, please.
Sure. So when you teach these intro level chemistry courses, you get very stuck in kind of your way of teaching the course and the content that you create and provide the students. Change is very scary. My advice would be, do not be afraid to try something new. If it fails, we're all scientists. Experiments fail all the time. But if it's a successful experiment, you're going to reap some rewards from that. So I would say just don't be afraid to try something new.
Fantastic. Thank you. And Bryn, you get the last word, since you're the wonderful initiative and sort of heart and soul you put into making this happen. So your advice to folks in your unique position of being a student and taking on this challenge.
I would say if you have any interest at all in anything to do with chemistry or business or any position that will be making decisions. Ultimately, you should at least look into green chemistry and take that initiative to ask either your professors or your teachers about it, or wanting to learn more about it, looking into those resources. Because not to be dramatic, but it's kind of our future to decide at this point. And I think that chemistry is going to be a huge part of how the rest of the next, whatever, 30, 100 years turns out to be.
All right. Well, thank you all very much for your time, for speaking to us all today, and thanks for allowing us to sort of put out into the world this model of what you all did here. It's pretty inspiring, and I hope the viewers agree.
Thank you.
Thank you.